Good day, everyone. I had a student who emailed me a little bit earlier today asking for some help with a couple of questions that were assigned, and the assigned questions were attached to the lesson that we most recently completed in Math 30-1 called the inverse of a function. I'm going to take a minute here and briefly go through what's important in terms of helping the student understand the two questions they are asking about. I'm not going through a complete review of all of the subtleties of the lesson on the inverse of a function. There's certainly a lot more covered than what I'm about to go over. In class, what happened in the warm-up is we were presented with a graph. It wasn't this particular graph of the function that is in blue, but it was some graph, and we were told this is a fact. This is a definition that if you take every single point on an original function and you look at the coordinates of a particular point and you switch the coordinates and replot it, then you're going to get the transformed point in the transformation function to inverse. This is what we're talking about. We're talking about going from a function to the inverse of a function. It's a transformation. What does that mean? Well, we can get specific here. One particular point on the function is here, and the coordinates of that point on the original function, the x coordinate is -7, the y coordinate is +6. What I've highlighted in yellow is telling you you're going to take those two numbers and you're going to switch the order of them, which means that -7, 6 is going to become 6, -7. And we plotted that image point, or sometimes what I call that sister point. So these 2 points are inverses of each other. What's happened is we have gone from this point on the original function to this point on the transformation, which is the inverse of it. So this is the mapping. We could say that the green is being mapped or changed into the blue, but more specifically what we've said in class is the mapping is x, y becomes y, x. And if you repeated that process with all of these points, you did that with this point, and this point, and this point, and this one, and this one, to get, here's the original function. You did that with all of those points to get this point, this point, this point, this point, and this point. So what I'm highlighting in blue now is the inverse. We discovered that those two graphs are reflections across the line y equals x. And that is really important for helping the student understand the questions that I'm going to be going over in a minute. We are simply swapping x and y for every point. The result is a reflection in the line y equals x. Again, there was a lot more we covered in the lesson than that. But using those main ideas, let's take a look at the 2 questions the student had asked about. The first thing you read in number 3 is it says the inverse comma x equals f of y. Well, I'm just going to make a note to you that when we have y equals f of x, that's the equation that we, or notation rather, that we typically use for a function, y equals f of x, and then you change it to x equals f of y, what we are talking about here is an original function and the inverse of the original function. Well, that makes sense because if you take a look at this and you switch the x and y, you get this. And that's a big hint as to how you're going to find the inverse of the function f of x equals 3/4 x plus 5 quantity squared minus 6. So what I'm going to highlight in yellow, everybody, is the original function, and I'm going to rewrite the original function, but I'm going to do so using y instead of f of x. So the original function is y is equal to 3/4 times x plus 5 quantity squared minus 6. And again, that's the original. I haven't inversed anything yet. This is the original function. In fact, just to make sure, I'll write the word original here. So now how is it we get the equation of the inverse? Well, the inverse is found by switching x and y for every point. That's accomplished in the equation by literally changing the y to x in the equation and changing the x to y in the equation. Now, unfortunately, that's not a choice in the four choices to the left. They are all in the form y equals, which is what we typically want to do with the equation of any graph. We want to take the equation and rewrite it as y is equal to. So now we're going to rearrange for y. I'm going to add 6 to both sides to get x plus 6 equals 3/4 times y plus 5 quantity squared. The y plus 5 quantity squared, which contains the y, before we can worry about taking the square root or getting rid of the 5, we have to get rid of that 3/4. Y plus 5 quantity squared is currently being multiplied by 3, which means we have to divide both sides by 3. Y plus 5 quantity squared is also being divided by 4, so we need to multiply both sides by 4 and get 4 multiplied by x plus 6 over 3 is equal to y plus 5 quantity squared. You're going to need to take the square root now. Of course, remembering from Math 20-1 that when you take the square root, you have to go plus or minus. So now we have y plus 5 is equal to plus or minus the square root of 4 times x plus 6 all over 3. We're going to subtract 5 from both sides. You should be accustomed by now to the fact that when you have things being added or subtracted from each other and there are square roots, we very often put the square root second. There would be nothing wrong with you writing plus or minus root 4 x plus 6 over 3 and then going minus 5, but we like to have the minus 5 in front. But unfortunately, when you take a look at the choices, our hopes and dreams are dashed because that answer is not there. However, you should recognize that 4 is a perfect square. It's the perfect square of 2. Since you are multiplying the 4 by the x plus 6 over 3, you certainly don't need to write this step, but since you are multiplying the 4 by the x plus 6 over 3, you can write that radical as root 4 times root x plus 6 over 3, and then you can take the square root of the 4 and replace it with a 2, because that's what root 4 is. So you get negative 5 plus or minus 2 root x plus 6 over 3, and that's equal to y. And if we take a look at our choices, that's choice A. So I hope number 3 made sense. Let's take a look at the next question, which I believe was number 7. A function is given by f of x equals x squared minus 5x plus 8. When we transform the function y equals f of x to x equals f of y, there are 2 invariant points. How are we going to find the coordinates of the invariant points? The solution to that lies in the fact that the only way you can get an invariant point is if it's a point on the line y equals x. Any point that is on this side of that line y equals x is going to be reflected across that line to this side of the line. The only way you can get a point which is not moving is if the point was on the line y equals x. So to reflect this particular point across the line y equals x doesn't make any sense because it's already on the line. And this is something we learned earlier on in the chapter, that invariant points for any type of reflection are points on the line of reflection. How does that help us? Well, it helps us because that means we're looking at where this function is on y equals x. And there's another way to reason it out, but if we're looking at where that function is on y equals x, we can simply say I need to solve this equation. And one of the ways I'm creating that equation in my head is I'm saying I'm solving this system of equations. That's one way you can reason how you get that equation. You're solving a system of equations. Another way you can do it, and this is how I think, I'm just saying to myself that an invariant point is going to be invariant because when you switch x and y, it's not going to matter. You'll still get the same two numbers. And that means that the y coordinate has to be equal to the x coordinate. By the way, this is a question that's very similar to something on your first assignment, which is due in a few days. Now all you have to do is solve this equation. It's quadratic, so you're going to zero the equation. We'll have x squared minus 6x plus 8. I've given you a bit of a gift in this question because it is factorable. What two numbers multiply to give 8 and add to give negative 6? That would be negative 2 and negative 4. What does that tell us? It tells us that x minus 2 can equal 0, or x minus 4 can equal 0. So we get two solutions for x. X can equal 2, or x can equal 4. You're asked for the ordered pairs of the invariant points. So one of the points is at 2, comma, the y coordinate. The other is at 4, comma, the y coordinate. But since these are on the line y equals x, or since when you swap x and y, you get the same set of numbers, the coordinates of the 2 points are 2, comma 2 and 4, comma 4. And there's a whole bunch of different, well, not a whole bunch. There are a couple of different answers here. You can go 2, 2, 4, 4 or 4, 4, 2, 2. Anyway, to the student and anybody else who needed help with those questions, I hope that was helpful to you. Take care, and I'm looking forward to seeing everybody tomorrow.